Hi everyone, let's talk about a Robinson annulation. So annulate means composed of rings. So an annulation is going to be a reaction which forms a new carbon ring. So our starting reactant, we're reacting with a strong base, hydroxide. So the most acidic hydrogens are going to be our hydrogens located at our alpha carbons. And there's one right here and one right here, and that's just relative to the carbonyl carbon. Now, when we think about which hydrogen is going to get deprotonated, we have to think about which one will be the most stable. And after deprotonation, there'll be a negative charge here or a negative charge here. So the negative charge here can participate in resonance with the aromatic ring, whereas this negative charge has less degrees of resonance, which is only with the ketone here. So we're going to see the deprotonation at this alpha carbon here. So I'm not going to write out the molecule again. I'm just going to act as if we've already deprotonated with our base. So we'll have a negative charge on that carbon. So thinking about what's going to happen next in the reaction, for one of our reagents, we have an alpha beta unsaturated ketone. And if we look here, this is actually an enolate ion, since we have a negative charge on the carbon alpha to the carbonyl carbon. So if you remember, this is just a Michael reaction. And if you're unfamiliar with the Michael reaction, definitely go back and learn about that before you try to learn the Robinson annulation. But we're just going to go ahead and do that step now. Our negative charge carbon is going to come and attack the beta carbon, pushing these pi electrons in between this bond and the pi electrons on the carbonyl and oxygen up to the oxygen. Then we're going to have the pi electrons we just pushed to the oxygen back down to form a ketone bond. These pi electrons here will come and pick up a proton from solution. And we'll be left with 1, 2, 3, 4, 1, 2, 3, 4. So we're going to be left with something like this. And since we still have base in solution, what's going to happen is our base is just going to go ahead and deprotonate the alpha hydrogen here. This base will deprotonate alpha hydrogen here, just as it deprotonated this alpha hydrogen here. Okay, so we're going to have a negative charge, in other words. So next we have a negative charge here, and a carbon with a negative charge on it is an extremely strong nucleophile. Extremely strong. So it's going to try to coordinate to a new bond by any means necessary, and the easiest way for it to do so here is to just go ahead and attack this partial carbocation in the carbonyl, because of course there's a dipole to the oxygen with the electron density, so we have a partial positive charge here. So it's going to attack here, and then the pi electrons in the ketone bond will be pushed up to the oxygen. So we have an oxygen with a negative charge here, and it will just go ahead and pick up hydrogen in solution to form an alcohol, and that's it for the Robinson annulation. But most of the time, we're probably just gonna heat the reaction up such that there's an elimination reaction that occurs here, and we'll be left with So what happens is, in an elimination reaction, the base comes in and deprotonates the beta hydrogen, and the beta hydrogen's electrons go to that carbon-carbon bond, which is formed here. In the process, our leaving group leaves here. So in our final product, we have a 3-ring compound. In the starting reactant, we only have a 2-ring compound. So we annulated a new ring. So when we step back and look at the reaction, it looks pretty daunting because there's so many steps. And I could have written out a lot of intermediates here, but the thing that you need to remember is that each one of these steps happens because it's thermodynamically favorable to do so. So that's the Robinson annulation, and I hope that helped.